Welcome back, everyone. And this is our last talk at the session at the track of remote talks. And Tim Nonner from TX Group will be talking about how to scale NLP.
So, hello. Thanks everybody for still attending my talk. Although it's a little bit late. Obviously, everything I'm going to talk about is joint work with the TDA and platform team. So some credits go to them. The topic of my talk is how to scale natural language processing just enough. And NLP actually stands for natural language processing. So if you expected a talk about neurolinguistic programming, some kind of bogus pseudoscience, I have to disappoint you. So it's going to be mainly about natural language processing, but we're going to dive into some machine learning stuff in general. So first, for everybody who doesn't know, what is actually natural language processing about? And natural language processing is basically how to make a computer work with language. And I claim that this makes sense for a digital media house that deals with a lot of text. And TX Group is especially tough nut because it operates in the Swiss market, and Switzerland is known for its many languages. So we have German, we have French, we have Italian, and we have the fourth language nobody knows anything about. So, and obviously, especially German is a difficult one. And there's a famous quote from Mark Twain who said that German should be set aside among the dead languages, for only the dead have the time to learn it. So I don't comment on this. So what's the main object we actually deal with in a digital media house? These are actually news articles. So let's look and try to understand a very simple news article. So let's look at this one sentence. It says, George Washington goes to Washington. And there are actually two important entities in the text. The one is George Washington, and the other one is Washington. So any language understanding should tell us that actually George Washington is a person and Washington is a location. And it's actually surprisingly difficult for a computer to distinguish between these locations and persons. Another thing that would be interesting to know about the sentence is what's the general context. So you could say, what are the categories? So in this case, because George Washington is there, it might be about politics. Because Washington is there, it might be about the USA. So having these four tags actually gives us quite a good idea what this article is about. But what is it actually good for? As one thing it's actually good for is to find related articles. So let's have a look at a different article that has the tags George Washington, New York, and politics. So there's not like a clear match because the one is about Washington, the other one is about New York, but still there's the overlap of George Washington and politics. And let's assume probably George Washington is a little bit rarer than politics, maybe only one in 1,000 articles talks about one George Washington. Whereas politics is in every 10th article. So we can compute some kind of similarity score by summing up 1/10 plus 1/1000. And this gives us a score that compares these two articles. And we can use this score to rank different articles and take the most similar ones. So that is like one reasonable application. Another reasonable application is to say, okay, we can actually get gender reporting. So since you already found the names, George Washington and George is very likely male, we can build gender reporting on top of that. And actually we did both of these things in practice. So here are actually two applications we developed with several colleagues from Tamedia. On the left, you see a GUI, which uses the technique I just showed to you to find similar articles. So you enter a search article, it detects the text in the search article, and it scores other articles depending on the overlap of text. So, and on the right, you see a gender reporting. It's actually built in a Slack channel, and it reports to you every day how many names of each gender are found in different categories, for example, on Tagesanzeiger. And this can be used then to mitigate bias in news articles. So we see actually that finding tags in news articles is actually a very useful backend for many, many different applications that look extremely difficult. So one might think, okay, this is maybe something very useful in general. And we can think about this process as a two-stage process. So first, we have something very abstract. In this case, these are raw articles. And we actually now want to find abstract features in these articles. And these features, in this case, are tags we can just store, for example, in a Postgres database. Abstraction, in this case, might be just, okay, if you see on the left, this is George Washington with all the details. And maybe you're not really interested in George Washington, just interested in that's a guy with a long nose, curly hairs, and old-fashioned dress. And if we have extracted these features, we can now use them in some application that exploits them to improve the user experience. So actually, that's a very abstract process, which is quite useful. Oops. So, and since it's a two-stage process, there are actually two stages where we can define KPIs on. In the first stage, we transform the raw articles into abstract features. And to do this, we usually use some transformation KPIs that tell us how good this transformation is. So this is very much in the realm of machine learning engineering. On the right, when turning the abstract feature store into applications, we are more interested in user KPIs, something like click-through rate. So this is more in the realm of data science. And hopefully these two different KPIs, they correlate with each other, such that if we improve on the transformation in KPIs, we also improve on the user KPIs. So, okay, this is really focusing on the tags. So just to repeat the whole process, so we start with articles, we turn them into tags. For example, we extract person entities inside the articles, and finally we use these tags to detect similar articles. But the process actually can also be applied in a completely different domain. For example, if we look at user-item interactions, we can use user-item interactions to build profile vectors of users and of items, and then finally use them in a recommender system. For example, the guy on the left is interested in umbrellas, so maybe I can also recommend him a hat. Actually, this has been something I've been talking about at TX 2019. So we see this is a very general process, but let's go back to the tagging problem. So how to do the tagging problem very concretely. So, and if we check online and Google, there are actually like literally hundreds of possibilities and APIs to do natural language processing and do tagging. And we looked at a few of them, for example, at Rosetta. And what can I say about Rosetta? Actually, the quality is really good, but usually even if you use some online API to do natural language processing, usually some tweaking is required on top. So you cannot really use the API, but for example, in our case, if we find the entity Trump and Donald Trump, we still have to find out that Trump and Donald Trump is actually the same person. So, and now we can compare this to standard, for example, Python package that we can just download for free. And I think the most popular one is Spacey. It's actually very fast, but we realized that the quality is actually quite limited. So we looked around for other solutions, and one solution that we found was Flare. Flare is also a Python package. It's actually much slower since it's built on PyTorch, a very general deep learning framework. It's modern, and I'm going to tell you on the next slide what modern means. It actually has an accepted quality, and it's multi-language. Since it was born at Zalando as an open source project, it has actually very good German support. That's just something we were actually looking for. So if I have to rank them on these two options, I would say probably like the Rosetta API is the best. Slightly better than Flare, and Flare is probably quite much better than Spacey. So one might think, okay, do we always have this kind of situation that, okay, if we want to have like better quality, we also always have to buy something like the Rosetta API, because that API costs quite some money. And I would claim that you usually have some kind of machine learning build or buy curve. So if you want to have something very simple and which is just maybe in some cases also good enough. It's actually okay to build it because you can build upon tools which are open source and freely available. At some points, maybe that solution is not good enough, and then you have to buy something like the Rosetta API. But in the end, if you want to have something that has an extremely good quality, for example, in our case, if you would want to have natural language processing that's also very good with Swiss German, which is something that obviously none of these packages supports, so we would have to train our own package. So then in this case, we would have to build again a solution. So, but in our case, actually, we found out that actually Flare is good enough for our purposes. So let me introduce you a little bit to the Flare Python NLP package. And it claims that it's a modern NLP package. And what does modern mean? Actually, it means that it also uses two stages. So first, it's heavily built on word embeddings. So, and the nice thing here is that you can freely combine different word embeddings and even complete document embeddings. So in this case here, actually we use a glove embedding and a fast text embedding, and they're actually just stacked on each other. So this results in a large vector for each word in the text we want to analyze. So, and this is fed then into a neural network, and the neural network in this case is basically just an LSTM, so it's completely standard. There's also a nice thing, so if you know PyTorch and LSTMs, you can understand the complete code. The LSTM is important because obviously in this case, you need to take the context into account. So you need to use the words goes to find out that actually George Washington is a person and Washington is a location. This process is actually quite slow. If you run it on a normal CPU, for large text, it might take up to 10 seconds. But in the end, this is actually not such a big problem because this is all for internal application. So we want to tag internal text, and so we don't really are not such in a hurry. The more important thing is actually throughput. Since we produce a lot of text, we have to be sure that we can do overnight runs to tag all of them. The problem, or like the solution would be here to say, okay, since it's a little bit slow, let's just run many of these tagging systems in parallel. The problem now in this approach would be, okay, we need at least 2 GB of RAMs just to store all these embeddings. And that's, if we now parallelize this and have a lot of processors that need to store these embeddings, that gets quite a lot, that results in quite a lot of memory. And so we developed a solution here, and actually it's a little open source add-on to the Flare package. And the idea is, okay, instead of storing all these word embeddings in RAM, it's actually completely fine to store them in a database. In this case, we just use SQLite, very simple. This allows us to have 6 times memory reduction. We add a little bit of lookup time because we get to receive the vectors from the database, but since the running time is anyway not that fast, adding 1 second of lookup time actually doesn't really matter. So it's a nice add-on, and this allows us to scale the whole solution on standard machines. It's now part of Flare 0.6.1, and some other guy even extended it to a different database about which I'm very happy about. So this was actually my introduction of the Flare modern NLP framework. So what do we have learned in this talk? We learned that abstractions are very important. And one question you have to ask yourself, what kind of abstractions do you need to support all your downstream applications? And I'm emphasizing here the word all, because usually building these kind of abstractions, more specifically some kind of tagging system and also a user vectorizer is quite a time investment. So you don't want to use the systems just for one application. You really have to have some kind of vision and to think about, okay, what kind of applications do you expect in the future? And what are the abstractions you need to support all these applications so you can reuse them? And then to create these abstractions, do you want to go for a build or a buy approach, or maybe try both or combine it? So it's also really not clear. Sometimes the one might be better, sometimes the other. And I'm convinced that in the case of text, at least in the case of new text, tags are actually quite a useful abstraction. So Thank you very much for your attentions. I'm really hoping there's still somebody around for questions.
Actually, we've got some questions. So,
okay.
yes, so let me ask you actually one question that I can see. How efficient are these packages when the input is a text with a mixture of languages? For example, German and English used in the same paragraph.
Oh, that's actually a good question. I'm not really sure about that, but the current model I'm using is actually multilingual, so it supports at least German and French, and probably some of the other standard languages. And the nice thing is actually you don't even have to tell the model what kind of language it is looking at. So it contains word embeddings for the specialists for all the different languages. So, and okay, mixing up different languages, probably it might still work. Maybe not if we're in the same sentence, but if we're in different sentences, pretty sure, yes, it does.
All right, we've got a lot of praise for your talk as well, and many thanks, but no more questions. But of course, feel free to reach out to Tim in the direct message. All the talks will be shared later on as well, so you'll be basically able to follow it. Okay, actually, I've got another one. Can we integrate this with Unity CMS IO?
Yes, actually, we want to do this. In mind, we have this application with the related article search, which is currently in a beta phase. And we have also a GUI, but the GUI is clearly not the one we want to use. So the ultimate goal is to integrate the search inside Unity.
For tonight, Tim, did you see anyone using or building JavaScript NLP libraries? Are NLP packages usually in Python?
I'm not aware of any JavaScript NLP library. There might be some, because JavaScript is also quite fast now. But I would assume that Python is the go-to language for all things data. So probably better option is to use Python.
All right, so thank you very much. And that was really interesting talk also for me. So I think it doesn't matter if you work in marketing, product, or technology, that's really available for everyone. And I'm really happy that we'll be able to share it later on. Thank you very much, Tim, for being an amazing speaker. It's the last talk for tonight, and now I hope we can all join our post-conference virtual drinks. Bye-bye, guys.
Cheers, everybody.